Scan-to-BIM is a technology that holds the promise of shortening the time between a question and an answer, so that when you look at a foundation and you ask yourself, okay, can we excavate? Within, a few moments of searching in your digital model, you can come to an answer.
Let's dive into it. I mean, so you started as an engineer. What was your experience like in school?
Waterloo, the University of Waterloo in Canada is notorious for being a very difficult engineering school. It's like top 3 or 4 in terms of difficulty. There's the University of Toronto, the University of Waterloo, University of British Columbia. And then, I won't round out the 4 so people don't pursue me in the comments, but it's known to be difficult. And I wanted difficulty because it is through difficulty that we grow. They are also very renowned for their co-op program. So they have a very intensive co-op program where pretty much every other semester you are out in the workplace and getting real-world experience. So you study for 4 months at the university, then you go and work for 4 months, and it alternates like that for 5 years. And I also thought that that was a brilliant idea because by the time you graduate, you have experience on 6 different projects at 6 different firms doing 6 potentially totally different things. It's kind of like a wine tasting for the work life. And once you graduate, you can make a far more informed decision on what you want to pursue. I would say those are kind of the things that make Waterloo stand out. And then, just all the usual stuff, late nights in the lab, working, just trying to survive, submitting assignments, getting back hard grades, having existential crises about whether this is right for you or not.
I mean, was there a moment in your academic career where you're introduced to the intersection of information and digital technology?
Yeah. So on a couple of these work terms, when going out and doing construction management, I was introduced to the power of information technology. So one of the first work terms was for a company called Acon Group. They're a big general contractor here in Canada, and they were working on a subway extension in Toronto. And this was still during the planning phase. So I start the term off, the project manager invites me into his office for some light chit chat, tells me about something that's going on the project that's causing him some stress. He says that they had just received a quote from one of the subcontractors, the surveyors, and their quote had come in twice what he thought it should be. Their quote was something on the order of $20 million. And again, this is a huge mega project, spans many years. So 20 million is not the whole fish, but it's still a big chunk. And he was expecting it to be somewhere around $10 million. And he said, I've been trying to figure out why there is such a massive discrepancy, and I just haven't been able to figure it out. You seem bright. Maybe you can piece things together. So I go back to my desk. I start to study all the relevant documents, looking through the monitoring, schedules, looking at the locations of all the survey points, looking at the tunneling schedule. And I'm thinking to myself, like, man, this is so complicated. I don't know how the subcontractor was able to combine all of these documents in their head to try to pinpoint like how much work actually needs to be done on any given day over the course of this several year project. And so I go back to the project manager and I say, I've looked through the documents and I have no idea how they come up with their $20 million estimate. Like, have you called them and asked them like what their method was?
Was it like a finger in the wind kind of?
Yeah, exactly. One thing you learn as kind of life goes on is that like most of everything is just guesstimation. Like engineers and technical folk like to put on a facade of numbers and calculus and spreadsheets. But at the end of the day, when time is tight, resources are never where you need them to be, Like you just go to your most senior person and they just use their gut feel intuition to just put a number to things. And, like if you're NASA, maybe you'll run a simulation or whatever, but not everyone has the resources that NASA does.
It could be 15, it could be 20 million,
It's crazy. And you hope that like at the end of the day with enough volume that all of these small discrepancies smooth over and everyone lives to see another day. But, like I had just, come out of the university where, we're doing very detailed technical analyses of all kinds of things. And so I said, let me try to figure out maybe there's something more accurate that can be done here. And so I say, okay, we have all of these documents, and when estimating the effort of this surveying, we have to combine them all. How do we take the information that's stored in the tunneling schedule, the monitoring schedules, the locations of all of the monitoring points, and combine them into just a single, unified yet simple representation of what is required? And so I said, okay, what do I have installed on my computer? Okay, I open up the applications tab and I see, okay, Microsoft Office. Okay. That's not a whole lot to work with, but maybe a spreadsheet can do the trick. So I open up the spreadsheet and I just stare at the cells and I think, okay, how do I get the information, all these documents into this one spreadsheet? So, okay, two dimensions. We have the distance along the tunnel and we have the date. And then I shade in the location of the tunnel boring machine on any given day, kind of streaking through the spreadsheet on a diagonal. And then I start to just brute forcing this data entry where I take the number of measurements that have to be taken on any given day and just start entering them into cells. And as time goes on, you start to, notice patterns in the types of measurements and the frequency of measurements. So you start to kind of copy and paste larger and larger blocks. But, it's just super tedious where for an entire week, 9-10 hours a day, I was just like entering data, copying data, entering data. Okay, doing some control. Okay, is this still matching the documents? But by the end of the week, I was able to tell the surveyor on any given day during the 5-year project how many measurements would have to be taken on any given day. And from that, they were able to assign the workforce, so how many people they would need on site, what equipment they would need on site. And with this spreadsheet, and the surveyors loved the spreadsheet, which I found surprising because I was cutting their budget in half with it. They were able to bring down the cost of the project, the cost of surveying.
Wow.
As life would have it, I never actually got credit for that spreadsheet. They actually moved me to a different project, like right after I submitted that. And then the engineer I was collaborating with took credit for it. But that's how life is,
How would you summarize that takeaway?
I've had a lot of time to reflect on this story as well as several other similar kinds of, problem solution pairs. And I've come to see that process of taking information that is available, it's just not accessible. The information is all there, but it's in a form that is impenetrable. You can stare at it until you're blue in the face and you won't be able to make heads or tails of it. And I use digital tools, software in order to transform the information. You combine it, you synthesize it, you filter it until it's in a form where it is simple to use. Like I took something where your only option was to stick your thumb in the wind and guess how much this thing would cost. And through a simple tool, a spreadsheet, I was able to combine all of these things such that you could just read out every row and knew exactly how much work needed to be done on any given day. And that transformation is something that I see just playing out over and over and over again in my career. And I hope to continue doing it because it's so powerful. And it's a pattern that is everywhere. Like there is this kind of information inaccessibility in every part of our lives, in every part of industry. You isolate a little part of the information ecosystem and it's this mess. That's the role I think we play. It's the role that a lot of technologists play, is how do we take this information chaos and make it accessible to decision makers?
Yeah. In many ways, I think what you're echoing is something that keeps me up, which is by our inability to not answer the what is keeping us from being able to proactively determine the what should be. I think this is particularly relevant in the built environment. And what we're working on, I don't think at least is anything new. I think healthcare, and when you consider, for example, the relationship between the human body and buildings, this is something that, I guess in healthcare we figured out, right? In order to determine what's going on in the body systems, you got to first understand what's the current condition. I suspect in buildings, the clearer we are to be able to determine visually what's going on in a building's architectural, mechanical, structural, furniture and equipment systems, the better we're going to be in a position as an industry to be able to just better determine what should be, even if that's as simple as how long is this going to take us to change or renovate or move. It's incredible that we've gotten this far with this kind of thumb in the wind approach.
I say that kind of tongue in cheek. Yes, a lot of the industry is just gut feel intuition, but I would say that a lot of thought leaders and commentators also have an unfair perception of the industry. Everyone says the built environment is kind of this laggard, slow to change, slow to innovate. And based on my experience, I would disagree. I've attended conferences as an academic, kind of dabbling in a number of different industries. And regardless of whether you're attending an event for construction or healthcare or aerospace or, insurance, every industry thinks that they are slow to change, slow to innovate, regardless of how advanced they may seem from the outside. And I hear this kind of repeated over and over and over again on every conceivable stage. And I think to myself, wow, the inside of an industry looks very different from the outside of an industry. And the thing that kind of drove this observation home was I was reading a book called The Checklist Manifesto by a medical doctor. I believe it was Atul Gawande. And he has a chapter in that book, or a section, I can't remember, that's focused on building information modeling. And this is a medical doctor writing a book about the power of checklists in managing work. And he has a section on building information modeling. Apparently, he had visited a construction site and saw a workflow focused on clash detection. And he was blown away by this. He was looking at the 3D model and the way that we were overlapping 3D models and looking for interferences so that things can be resolved in the virtual space as opposed to in the field. And he thought, holy crap, the construction industry is so advanced. And I'm reading this, I'm like, yeah, I guess we are. And I just went to GeoWeek 2024, where we're talking about drones and lasers and radar. And yes, parts of the industry are slow to change and slow to innovate, and rightfully so, because we're dealing with massive risk. But there are also people like you and me, and the people at GeoWeek, and the people that Atul Gawande visited on this construction site that are pushing the boundary and really testing this assumption that we are slow to change, slow to innovate. And yeah, you mentioned the healthcare analogy and how we're kind of diagnosing buildings and trying to figure out what is. And I was just reminded of that book.
I've got to check this out. So I'm curious, in this, what is the role of reality capture. And I wanted to kind of purposefully distinguish between building information modeling and reality capture. But maybe we start there. And your spreadsheet story is perhaps a form of reality capture in some ways. But where are we today? Take us back.
So I was just wrapping up my undergraduate degree, and I had coffee with a professor by the name of Carl Haas. He runs a very interesting lab focused on reality capture, computer vision, and just construction optimization in general. And he saw that I was kind of a bright young upstart, and he supervised one of my internship reports focused on automation of progress tracking. And he thought, wow, this guy should go into grad school. And he was right. I really flourished in grad school, and I loved every minute of it. He introduced me to LiDAR laser scanning, particularly on a project focused on quality control. We were collaborating with a general contractor that was fabricating pipe spools and shipping these pipe spools to site. And it was a recurring problem that these pipe spools just wouldn't fit where they were supposed to fit. The interfaces, the things, the holes where the bolts go in, just none of it was aligning. And the labor had to bend these pipe spools into place using all kinds of unseemly techniques. And the contractor wanted to know, is there a way we can discover this kind of misalignment earlier in the supply chain? Ideally, we would discover that there is something off the moment that the pipe fitter and the pipe welder fit things together. And so Carl said, yeah, there's this new technology called laser scanning. Maybe it holds the solution. And so laser scanning is kind of like a bridge between the physical world and the digital world. And both sides have their benefits. Reality, of course, knowledge of reality is important because that is the space where most of us operate. And if something is off in reality, that will have real world consequences. However, reality has shortcomings. Moving through reality takes time. We're limited to see only the things that we bring our eyeballs close to. I can go on, but these shortcomings can be overcome if we create a kind of a digital replica of reality. Once reality is digitized, all of these shortcomings disappear. We can teleport everywhere within this replica in an instant and observe almost every feature and aspect of reality instantaneously. This makes it a little more amenable to analysis. So laser scanners acting as a bridge are the tool that allows us to bring reality into the digital space. Of course, you can hire a human to just go out and take measurements and then do data entry, but then you're limited by their capacity. A laser scanner can take millions of measurements very quickly. And you can, with modern scanners, something like a backpack, you walk through a building and within an hour or two have digitized that entire building. And yeah, of course, you can send an inspector in to look for a particular problem. But once you have a replica, you can look for almost every conceivable problem simultaneously. And all of that capability is provided by a 2-hour walk, a stroll through the building. So as a bridge, it's very powerful. We leveraged it to do analysis of pipe spools. So we would set up the scanners in the fabrication facility. We would laser scan the facility. My algorithms would then isolate the pipe spool from the rest of the point cloud because, of course, when you set up the laser scanner, you don't just capture information about the pipe spool, you capture information about the entire facility. We isolate the pipe spool, compare it with the design file, and discrepancies between the design file and the fabricated pipe spool could then be reworked while it was still within arm's reach of the pipe fitters and the pipe welders, which is the cheapest place to do rework. That kind of analysis, How else would you do it? I don't know, but definitely not as easily as with a laser scanner. And the technology has only advanced since then. That was with a extremely heavy old Faro, I think it was Photon or something like that, where the battery had its own briefcase. And we had to plug this thing into a laptop while collecting data. The thing would always malfunction. We'd have to reconnect, restart, reboot. It was a nightmare. Now you have these super sleek, elegant devices, some of which are the size of a phone. In fact, some of them are phones. You just kind of push the power button, start, and it just collects data, super reliable, easy to use. Yeah, I mean, that causes problems in and of itself, because now you have this massive inflow of people that are just buying scanners and calling themselves surveyors, which is dangerous. But yeah, that's kind of the state of the industry. You can attach these things to drones and robot dogs. I suspect that very soon these kinds of devices will be extremely cheap. And, I was at GeoWeek, and one of the presenters, the founder of I'm forgetting the app, something like Any Point or Every Point.
Every Point, yeah.
He said that within 10 years, he suspects that every square centimeter of the supply chain will be digitized in real time constantly as just a data stream. I don't know how that will be achievable, but I mean,
in what sense? The supply chain of...
I think he used supply chain as a way of referencing every kind of space that is economically relevant. So like, from the moment that resources are mined from the ground all the way to the moment it hits a user's or a consumer's doorstep on delivery. Like every space that is relevant in that A to Z of extraction to delivery is going to be digitized. He said this quite confidently. He seems like a smart guy, and it's kind of a controversial point because there are privacy things, data sharing things, like political things that are all involved in that kind of massive transparency. But maybe technologically it may be feasible in 10 years with smaller LiDAR sensors that are mounted to equipment and to headsets and things. So who knows? But that was a very bold prediction.
I mean, let's run that thought experiment. I guess even further, I'll pose a question. What has to be true in order for us to be able to accurately digitize? I believe the estimates I've heard is 1.6 billion buildings, which sometimes wrapping your arms around what that actually even means is really difficult. But what needs to be true from perhaps technical, economic, just industry-wide, needs to be true in order for us to accurately digitize buildings once, I guess, let alone an infinite stream of feedback loops.
Yes. Of course, there are almost an infinite number of advances that need to take place, but I will call out one in particular. During my PhD, I was working on kind of a side project that I called the General Model of Productive Information Systems. Super nerdy. It hasn't even seen the light of day. I tried to get it published, but yeah, it didn't get very good reviews. However, in the creation of this model, I had an epiphany that has kind of stuck with me. And in creating this, I took kind of courses online on information science, information technology, and I was like obsessed with this idea of increasing like information sharing and information interoperability. Like, how do we increase the accessibility of information? Because those were the lessons that I learned from these early construction management projects. It's like, okay, we have all this information. How do we make it more accessible, And the epiphany that I had came when I was listening to a lecture on cryptography and secrets. And The reason this lecture kind of stands out in my memory is because it runs counter to this philosophy of increasing accessibility, where before listening to this lecture, I'm just like, we need to, connect more things, more sensors, more sharing. And this lecture was all about decreasing accessibility, closing things off, isolating them, keeping them secret. And I thought, wow, there is no place in my general model of productive information systems for this kind of mechanism of blocking accessibility. And I thought, like, why? Why is that? And this leads me to the one enabling technology of what is going to enable us to digitize 1.6 billion buildings. And the thing that is going to enable this is very strategically increasing the inaccessibility of a lot of that information, because the information that will be produced by digitizing 1.6 billion buildings will be utterly overwhelming to us, as well as the people we try to sell this information to. And so in the price of maximizing access to all of this information will be just a total disorientation, like not knowing how to use it, not knowing what to do with it. And so the one enabling technology is, how do we now take 1.6 billion buildings worth of information and hide most of it? Which is crazy. You go through all this effort of collecting the information, and now we must hide 99.99999% of it, so that the 0.0000001% that is most valuable can be surfaced to decision makers. And it is this hiding, this inaccessibility, that is the thing that is going to enable this technology to be useful. And once it becomes useful, then we will see it manifest, because things only become manifest when they, are seen as useful by investors and, employees that are developing the technology, the first users, the people that pay for the data. It's funny that, initially I was all about inaccessibility, and I still am, but the thing that improves accessibility sometimes is actually blocking information from ever being perceived by a user.
You nailed it. I think from another side of the table, I would have mentioned that it's kind of the choice paradox, where it's like you present so much information that there's almost this paralysis. Is like, we don't even know what to do with it. And the process by which you either hide or, I would have talked about curating. Here is the kind of first principle information. We could dive in deeper rabbit holes about, the infinite amount of metadata attached to these digitized models of buildings. But I do ask myself, there's a few basic questions that, whether you are Thomas as a construction intern, or a civil engineer, or an architect, or a building owner, and perhaps starting with kind of layer one. And I often find that those layer one questions just try to touch on the most basic things, like how big is something? How much of something is there? And if we can answer some of these basic questions in structured formats, this is what I get really excited about.
What really drew me to the approach that Integrated Projects has taken to the Scan-to-BIM process, I wrote a paper on digitizing existing buildings. And in the part where I talk about and introduce building information modeling, I talk about all of these different aspects of a building that can be represented within a building information model. We have, of course, the geometry, but then there's material properties. We have pricing, we have schedule, we have manufacturer information, we have structural analysis information, and the list goes on and on and on. Everything that someone might find relevant about a building can conceivably be represented within a building information model. And this kind of poses a problem because, we don't have unlimited resource. And so fundamentally, building information modeling is a process of selection. Like, what is important and what is unimportant? What is relevant to this situation and what is irrelevant? And that decision is difficult even just on a single project. But now what integrated projects is tasked with, and what I think we have done very skillfully, is deciding that distinction just in the abstract, in the general. Like, okay, we serve, hundreds, thousands of customers. What, minimal standard set of relevant information should we be including in our models? And for a task that is challenging, even on a single project, you did it. You know how difficult it must be to try to answer this question for hundreds, if not thousands of customers. That's a question that we've been wrestling with for the entire existence of the company. It's a question that we will continue to wrestle with. And it's a question that the industry will need to wrestle with once, sensors proliferate and algorithms for processing the data proliferate. Like, what is relevant? What is irrelevant? What should be selected to be included in these models?
It's okay. It's okay. You touched on so much there that I think is relevant to not just the industry, but like company building, like knowing what chapter you're in as an industry and as a company and as an individual, I think is so critical. I think one of the challenges as a company, when it seems like the world is your oyster, meaning like when you have infinite amount of options to go into, I guess saying no is often more important than saying yes to everything, especially when you run a business, because to your point, when resources aren't infinite, you then kind of forces you to ask, well, then what's the highest return on effort right now in this particular chapter, given what we know? And perhaps given where the market is and the maturity of where the market is, where technology is, et cetera. And I found that the irony is the more niche you are, that allows you to actually be even more specific. And so that's, I'm sure, a constant tension we're always going to face is like the counterintuitive thought is to like, hey, the more specific we are, the more we can connect with a broader audience. And I found that to be true, that in kind of as we double down on becoming the best in the world at kind of one particular thing, it tends to open up new audiences that we didn't even consider were potential audiences or use cases, et cetera. And then kind of expanding in that way. To double click on a subject here, so Scan-to-BIM, let's zoom out. If we had to explain to the non-technical, non-real estate person as to why Scan-to-BIM even matters, how can we begin to put into context as to why this particular kind of technology or process matters for kind of just the built environment as a whole?
I think it was in 2017, I was given a tour of a hotel in London called Claridge's, and they were excavating 5 additional basement floors underneath part of their existing structure. And the engineers had to answer a question, and it seems like a simple question. When we start to excavate these basement floors, is the foundation of the existing building going to collapse on us or not? And to answer this, you just have to know, like, what is the structural steel situation within this foundation? With documents, it would be a trivial thing to answer. They approach the owner of the hotel and they request documents describing this foundation. And the hotel is over 100 years old. And either the documents were never created or they had been lost or damaged at some point. But for whatever reason, the owner didn't have these documents. And they said, sorry, you're on your own. And well, how do you answer like what is embedded in an existing foundation without design documents? Like you can start to demolish the foundation to try to find out what's inside, but that kind of defeats the purpose. You might as well just rebuild the foundation, which is not an easy thing. They were lucky in one way, in that the hotel is kind of culturally prominent. It's a kind of a home away from home for royalty and celebrities. And so they thought, okay, it's kind of a long shot, but maybe a reporter or something wrote something down in a technical journal. So they went to the architectural archives. They went through these non-digitized volumes, and they found in an article from 1931 of The Builder, a single sentence. I don't know how they found it. It still blows my mind. You know, a foundation was laid of the footprint of the existing building, 4 feet thick with 75 tons of steel. And that was what they needed. It told them the mass of the steel, and they did a little bit of destructive testing to verify positioning and sizing and things like that. But with that clue, they were able to decide, okay, it's safe to excavate. Let's go ahead with the project. And I love this story because, one, it's super unusual to have this kind of opportunity of finding like a clue in an architectural archive that's relevant to an engineering decision. So it's interesting in that way, but it also demonstrates a pattern that just repeats itself over and over and over again in the built environment with professionals that deal with the built environment, is that you have a question and then you kind of slog through this process of like searching for information, retrieving information, combining information to make some kind of you would hope, an informed decision, and then you can take an action that makes progress. Scan-to-BIM is a technology that holds the promise of shortening the time between a question and an answer, so that when you look at a foundation and you ask yourself, okay, can we excavate? Within, a few moments of searching in your digital model, you can come to an answer. The question is how do you bring that information closer and closer and closer to the question so that you don't have to go to the architectural archives? Scan-to-BIM gives us an opportunity to collect just a broad set of information that acts as a kind of a foundation for decision making. So rather than going out and taking one particular measurement that can answer a very small set of questions, you go out and you collect millions, if not billions, of measurements that can conceivably answer a much broader set of questions. That's why it's a foundation. So you go in with a laser scanning device, you canvas the entire infrastructure with measurements, and then you convert those into a model. The conversion of the model is that very important selection process that we were talking about, where the data coming off of the laser scanners is beautiful to look at, kind of difficult to use for much of anything unless you're super technical. Conversion to a model now takes the information that's in that scan data and makes it accessible to a broad ecosystem of existing architecture, engineering, facility management, and other management tools that only accept as input a model. So from A to Z, scan to model, we can hopefully shorten the time from question to answer. And yeah, it's still a new technology. It's only about 10 years old. I don't know, maybe a little older, but yeah, it's improving quickly, and hopefully with the contributions that Integrated Projects is making, it will become much more ubiquitous.
What additional step needs to be true in order for us to grow from information models that architects and engineers could understand to a world in which your average non-technical person that engages with buildings, which is all of us, can actually ask questions about the walls, windows, floors, doors around us? Like, what's that extra step? Scan-to-BIM to, what's that third leg?
I think the end game here is just a well-defined set of use cases. Because you put any technology in front of someone that is unfamiliar with it, and they'll just stare blankly at it because it's unfamiliar. And how many of us are willing to stare blankly at a piece of technology long enough for a use case to pop out the other side? Not many of us. Not many of us have even the luxury of time to do that, not to mention the passion or the interest in doing it. And so in order for the models that we produce to be broadly used by people that aren't engineers and architects, we need to put in the effort of identifying use cases. And these use cases need to be so compelling that they are able to compete amongst all of the other activities that someone can do during the day. So as a homeowner, like, why would I care about a building information model as compared with, walking my dogs or taking out the trash or sitting in traffic to get to work or dealing with, some family problem? Well, it would have to be so useful that I would be compelled to use it. So what are these use cases? Okay, well, a homeowner occasionally has to do a renovation. Do all homeowners renovate? I don't know. Some people hire contractors. Some people, get favors from family. Like, all of these things are so complicated. And so, okay, the simplest use case is, okay, you have to do some kind of a renovation or an analysis within your home or your apartment, or you want to, replace windows. Okay, for step number one, how many windows do I have in my house? Okay, I guess I can run around and try to count all of the windows. Well, okay, do I have the time to do that? Okay, I have to go pick up, groceries. I have to, finish this assignment maybe from my work or whatever. Okay, when am I going to have the time to go out around and Okay, I found a little moment. Okay, I'm going to run around. Okay, did I miss any? And then there's the stress of figuring out, okay, did I miss a window or not? Okay. So maybe there is a use case here. If you had a model for the building, you would just sit down at your computer and you would say, how many windows in my house? Okay, 17. Oh, wow, that was easy. I didn't have to do all of that stressing about planning, about missing things. I just kind of get the number and, okay, well, what do I do with this? Okay, I want to send this off to a window supplier in order to get a quote. Okay, so I'm going to plug the 17 into my email. I send it off to the supplier. Maybe I also include a more detailed schedule of windows with sizing and the kind of the general style of windows that I'm looking for. If we can unlock these kinds of use cases to say, okay, the architectural model, the engineering model demands that the professional know how to use the model. And the professionals are trained to use the model. However, not everyone has the luxury of that training. And so if we can provide, instead of a use case, we provide a kind of a menu of use cases, they don't even interact with the model. They don't care about the model. They want quote from supplier for windows. Click, and everything else is taken care of for them. If we can provide them that menu, I think that is kind of the end game that will broaden the market for this kind of information.
I think that kind of commercialization is exactly what has to happen. And yet there's so much packed into a future like that, right? There's the assumption that we can accurately 3D scan the space that you and I are sitting in right now. So that's challenge number one. To your point, the scan itself is often relegated to very low use cases and very technical folks. Assumption number two is converting that to an information model that then grows the use cases from just point cloud segmentation and 3D scanning specialists to now architects and engineers gets really exciting, because now, to your point, the next time Thomas needs a renovation, he could just simply pass that 3D model onto his architect or engineer. The third jump is, I think, what we're starting to see now, and we're very much in this kind of first inning where, assuming that the first two things were true, and assuming that we're now bringing buildings online at a scale at which is compelling, you can very easily imagine downstream effects of this where Thomas can very easily kind of connect his building, whatever that means, where we can now instantly quantify, visualize, and verify the surface area of walls, or to your point, the quantity of windows or quantities of chairs and desks that, that are in that space. That's incredibly valuable data, both for Thomas, but also for the folks that are likely wanting to work with you to replace that. Now, for a moment, I remind myself that buildings have descended to the forefront of our biggest challenges in the environment. I think there's tons of numbers being thrown around, but I think 40% of all carbon emissions are buildings. And it's not even close. I think the next industry is transportation at 27% or something. So today, the buildings that you and I are sitting in are contributing by far the largest amount of CO2 in the environment. And I think the key to doing something about it is understanding what exactly is happening in these buildings. The challenge, of course, is that, unlike the exteriors of buildings where Google and other satellite imagery can project, the insides of buildings are really private and they're hard. And getting access to this stuff is really hard and difficult. I think there has to exist a consumer base that is almost wanting to digitize their space. I think about what would encourage you and I to 3D scan our apartment. There has to be something at the tail end of that, right? It can't just be a cool 3D model. That would, for architects and engineers like you and I, that's pretty cool. But for most folks, there has to be some reason I would want to do that. Now, my hunch is that I think it might, most things, start with gaming. I don't know, if I 3D scan my apartment, maybe I could host some sort of virtual sleepover or something. I don't know. That might be the kind of low-hanging fruit stuff. But then to your point, you take it a step further into commercialization. It turns out that if I can accurately quantify my furniture, that's probably data that companies like Amazon and others would probably want, because then they can proactively try to tell you, hey, you need to swap out that mic for a better mic. Am I jumping the gun, or how far are we from this kind of mass connectivity where now, anything down to the quantity of rugs can be known?
If big tech has taught us anything, it's that for the right price, we'll sell our souls to the corporation. It's all about value prop and the use case. If you can show the consumer what benefit they will experience from having their space digitized, they will gladly digitize it, so long as the benefit is great enough. The question is where is that threshold, and how do we make people even cognizant that there is this opportunity? It's unclear to me what the killer app for digitization is. Is it going to be automation of a vacuuming robot, or is it going to be some kind of Tesla Optimus cleaning and assistance robot? Is it going to be I don't know, maybe some kind of interior design subscription service where every year you get a total makeover, but you don't own any of the furniture, but you get it swapped out every year or something like that. I don't know. In order to enable some of these things, you would have to have presumably a digital model of your dwelling. This might be just a total tangent, but one thing that I am personally very excited about when it comes to digitizing the spaces that I occupy is almost as a kind of a memory tool. So there's this competition that runs, I can't remember exactly what it is, Memory Mind Masters or something, where people just memorize decks of cards and the order of all of the cards within the deck. And, the highest performing champions get several decks, not just a single one. And there's a time trial. It's totally nuts. And the method that they implement, at least one of the most common methods that they use for memorizing these cards, is they assign a kind of a meaningful character to each card. And these characters can be from cartoons and family and just books that you've read in the past, but they have to be meaningful characters. And then you take a space like your home or your neighborhood or your workplace, and you kind of map out a route in that space. And then as you look at the cards, you take the character that is attached to the card, and you have them performing some activity within that location, that anchor within that space. And then as you flip through the cards, you kind of progress through the path that you've predefined through your neighborhood or through your home, and you're attaching characters to anchors along the route. And so now when you have to recall the card deck, you just recall all of the activities that all these characters are performing along the route within your home or your neighborhood. And it works really well because kind of our brains are programmed to remember kind of people and faces and characters. And they're also really well programmed for navigation within space. And I'm thinking, wow, wouldn't that be incredible to just have like a tool that automatically maps certain types of information to specific places within my physical environment. So now, rather than kind of navigating, folders and directories on my computer, now when I want to work on, my project related to mosaics or whatever, I now have to walk to that location where my files are quote unquote stored. And just by moving my physical body to that location that has been designated my like hobby space, my brain actually resets itself and becomes more kind of embedded within the hobby mindset. I kind of learned about this concept, I can't remember where, but they're called like sacred spaces that are designated to just like a single type of activity. And there have been studies that show that if you designate a space to just a singular type of activity, you can perform that activity in that space with far greater intensity. And that kind of makes sense, like, mood and all of that, like your physiology changes. You kind of like enter that state of being of like, I'm doing arts and crafts now or whatever it is. And that's kind of an application of this spatial technology that I'm personally really excited about, is how do I map all of my knowledge and information and activity to spaces within my environment, the coffee shop, my living room, my office, my parents' house or whatever, such that now instead of just navigating to a directory, which provides, a certain kind of experience, I now am writing my memoir or whatever. And I only do that in the sunroom of my parents' house. And it's unconfirmed, but I feel like that will provide me with a certain kind of a benefit where I can approach all of these activities with far greater intensity. And that kind of mapping can only be done if I've digitized all of the spaces that I find relevant to me. There'll probably be some kind of analysis for appropriateness of the space for a particular kind of activity. Like you're not going to want to do work in your bathroom, for example. And that kind of analysis will need to be automated as well. I'll treat it almost like a library of the mind, where you walk into a library and like all of the topics are kind of sorted by subject. And, you want to learn about history, you go to the third floor in the West Wing. My life will be similarly organized where, okay, I'm working on my article for my blog. I go to my brother's house in the basement sitting room or whatever.
Well, I mean, let's dive into the nuts and bolts. So I'm reminded of this quote as we shift to what are the challenges of automating the process of digitizing. There's this great quote by, I think it's Picasso. I could be completely butchering it, but something along the lines of like, when you talk to art critics, they'll spend their time debating about meaning and purpose and whatnot. And yet when you talk to artists, they'll spend their time asking each other, where can you find the cheapest paint? and so just to dive into the nuts and bolts for a second. So Scan-to-BIM, I consider you to be one of the foremost experts in this challenge of point clouds, segmentation, and what it might take us to go from a file format of fairly low use cases into this conversion into a standardized information model. What challenges do we currently face, perhaps not even as a company, but just as an industry, for automating Scan-to-BIM? We've heard a few times people talk about it as like the holy grail. Like if someone can take their iPhone out, 3D scan their apartment, click a button, get an accurate 3D plan, and instantly, that's the ambition. What's keeping us from getting there?
So Picasso also had a piece of work. I can't remember if it was a painting or a drawing or a sketch, but it was called, I think, The Bull. And the purpose of the bull is to kind of provide us an insight on something that he is famous for, which is abstraction, where the bull shows a kind of a series of bull images of decreasing detail. So you start off with a really detailed bull, and then the next one is a slightly less detailed bull. And as you progress through the images, the bull becomes more and more abstract until the final one is just a few brush strokes. And there's kind of a beautiful connection between that idea and Scan-to-BIM, where on one end you have this super detailed point cloud laser scan of your existing building, and on the right you have just like a few simple geometric volumes within your building information modeling software. But the challenges, I can get into the nitty-gritty of how these technologies are implemented, but I'll start by maybe referencing a library that's been created by our quality control and quality assurance team. They have produced a library of many thousands of quality issues and pieces of feedback. This is essentially like a massive database of all of the ways modeling can go wrong. And that is what makes Scan-to-BIM automation so difficult, is that there are thousands of ways modeling can go wrong. And it's one thing as a human modeler to read a piece of feedback from QA/QC and implement a fix. It is quite another to, as an automation engineer, to try to preemptively avoid all thousands of issues. That's what makes it difficult.
But that's actually a great point. It's like we are producing these 3D models to the tune of several hundred, buildings per month at this point. And every single one comes with its own set of a few dozen or so challenges that a human specialist has to 3D model. Human QA/QC specialists have to then review that, provide feedback, fix it, etc. And that kind of exchange happens 2, 3, 4 times per building that we deliver. To preempt that entire process.
Yeah, it's not easy.
Yeah.
But I will say that the framework that Integrated Projects has created definitely makes it easier than if I was in other environments. Like the thing that really drew me to Integrated Projects is just the quality of the data set, of the quality control, quality assurance process. Like QA/QC has actually gone through the effort of outlining all of the quality issues that have been identified over the last few years. Like, as scary as a list of several thousand issues is, the fact that it exists is a massive advantage over an environment where the issues have not been identified with such rigor. I try to imagine being one of these Scan-to-BIM automation tool vendors where you are developing your tool in kind of isolation, kind of like a real separation between you and the users. I'm lucky that my users are within the same organization that I'm in. If I was developing these tools in isolation, you struggle through all of the challenges of actually implementing an automation system. And it's hard because, you're dealing with, very diverse data sets. You're dealing with high volumes of data, and you finally get something that you think works. And then you send it off to a customer to trial it. They say, we can't make use of this. That is not a productive environment for development, because there is such a tight coupling between our automation team and the QA/QC team, where I can just send a message, they look at a model, they give me detailed feedback, and I can continue to design and iterate. That gives us a huge advantage. And so, couple thousand issues, sure, but we can pick away at that over time. And we're not going to boil the ocean. We're going to identify, the core set of model components that we want to start with. We really get those right. We make sure that they actually speed up our modeling process. And over time, we're going to win because we're in such a strong position. The data set is high quality. The data set is super standardized. We have a very good relationship with our quote unquote users, our internal QA/QC team. It's an opportunity that I feel other companies and competitors are going to struggle to replicate. I can also talk about, what I think are, other companies are facing. Like, other companies are also doing Scan-to-BIM. We're not the only Scan-to-BIM service provider, and some of them have been in the game far longer than we have been, and they probably have very comparably sized data sets. But in automation, variability is the enemy, where, from one year to the next, you adopt a different template, you adopt a different naming thing, you take on a customer that wants a little bit of customization, a little bit of tailoring. One team, comes, another team goes. Like, everyone has their own individual practices of approaching things. They're like one-off privacy and policy issues that, okay, we can't use this subset of the data or whatever. Like, all of this kind of compounds so that if one of these Scan-to-BIM service providers partners with, an artificial intelligence, star team, they're going to look at this data set and they're going to cry inside, because it's not a data set that is ready to be exploited. It's not a data set ready to be leveraged. And so, okay, now they have to decide, okay, do we actually pay for someone to go in and clean all of this data? Like, who's gonna go in? Like, okay, do you train, a data cleaning specialist firm in building information modeling to go in and clean all of this? Like, okay, maybe it's worthwhile, but like, are you willing to pay a couple people for potentially years to just sit and clean data with no guarantee that all of it is going to pay off? Like, I don't know, maybe an Autodesk or one of these large platform players that have the resources to do that. Like a Scan-to-BIM firm with, several dozen employees, maybe don't have the kind of R&D resources to fund that kind of effort. We don't have that problem. Like, you and the rest of the founding kind of team, you guys sat down, you put together the execution plan, and you stuck to it. And that has made my job a lot easier, because with the execution plan, laying out standards and expectations, I look at the data set and it's just like a perfectly manufactured, component where it kind of just slides right into place and requires very little cleaning and rework and things like that.
It's not lost on me that I think what we're touching on, if we're successful, is a really big, big deal. I mean, if we're successful, what it means is that while we are getting faster and, because of that, we're also producing information models at unit economics that allow us to then drop our prices even lower, which then presumes more people can get their hands on accurate information models. While we're doing that, we're also suggesting that we're able to quantify the parts, pieces, component, like the DNA of a space, which is kind of insane to think about. How do you think about the roadmap? So I think what I got really excited about your work is that while we know that automating Scan-to-BIM is the holy grail, we had to kind of, to use your term, not boil the ocean. So we had to kind of break it up into certain phases. And it'd be great to highlight, we recently just submitted and got a kind of provisional patent for milestone number 1. Dive into that. I mean, what does that mean for us? What does that mean for the industry? How is that a stepping stone to milestone 2?
I'll say that the onboarding process for integrated projects was really world-class. Like we sat down, we thought about, okay, what does like the first year of the work look like? We identified a few kind of key contributions that can be made by automation. The first of which was answering a simple question, like what is the floor area of a scanned building? Right now, like building measurement services, commissioned by an architect or someone similar, they go in, maybe they laser scan, maybe they use existing floor plans, and they go in and they just manually trace the boundary of types of areas, classifying things, and then they provide a kind of a floor area report. This thing can cost thousands of dollars. Because of how foundational floor area is within management of the built environment, it literally touches every decision that is made. You'd think that there'd be an easier way to get a kind of a ground truth. You don't have to commission someone to go out and do all this measurement manually. We thought maybe it's time that this was automated so that we can just kind of have a button in our platform that says, what is my floor area? And you just get an instantaneous estimate. Yeah, so that was milestone number 1. Can we leverage nothing other than a laser scan point cloud and use advanced tools in machine learning and artificial intelligence to estimate the floor area? And this is challenging because, of course, the diversity in the data set, the fact that laser scanning can also include exterior spaces. It can include spaces inside that fall inside or outside certain, building measurement definitions. And so, of course, there's, we have to approach it with great care. But we have the first version of this system running internally so that we can monitor it, we can improve it, we can iterate it. We filed the patent. And we are, with essentially a click of a button, estimating floor area from scans of existing buildings. We're not at a point where we're ready to maybe make it user-facing. We're still working through some of the kinks. It is a V1. But very soon it will be, feeding automated location reports and things of that nature. I don't know whether it will replace building measurement services in the short term, given how important floor area is. But if you're not acquiring a building or something of that magnitude, I think it will be a welcome tool for a lot of people that operate in the built environment. That was milestone 1, where we've just started work on milestone 2. This is Scan-to-BIM V1 for simple architectural components. So think of things like slabs with no slope, walls that are aligned with the principal axes of the building, doors and windows and columns and things of that nature. We already have kind of a prototype system that's kind of cobbled together. And again, we're putting it in front of QA/QC to get feedback on quality issues and how exactly should the output of these neural nets be brought into a modeling software in order to genuinely speed up the modeling process. Because the last thing we want to do is automatically generate a model that we just have to delete and start from scratch because of just how janky it is. That's kind of been our experience with some of the existing automation tools where they're almost not worth adopting because the rework takes longer than modeling from scratch. And we are trying to avoid that at all costs. And we are making progress. And hopefully sometime in this quarter or next, we'll have a running system that is providing a real benefit, a reduction in modeling time. And then we'll progress to milestone 3 and 4, which are also focused on the architectural scope of modeling, just looping in more and more complexity, diagonal walls, curved walls, slab openings, just like bringing in all of those thousands and thousands of quality issues, trying to figure out which ones are worth tackling, which ones are better suited for a human modeler. And as time goes on, just developing this kind of a collaboration between the automation system and the humans that do the hard stuff, the stuff that automation simply isn't ready for.
To expand on that, what are the implications for the customer at the end of the day if we're successful? And also, what are the implications for folks like you and I, or BIM specialists around the world that are wondering, the same question I guess most of the workforce is wondering right now is AI going to take my job? What's the role of a BIM specialist in that context?
The benefit. So I'll reference 2 things. So there's this quote by Thomas Edison, and he said his goal when he was inventing the light and kind of developing the early electric industry is that we are going to make electricity so cheap that only the rich will burn candles. And I love that because it's not just like profit maximizing capitalist type thought. It's actually trying to make a real impact on the world in a way that truly benefits the consumer, like driving costs down rather than trying to drive costs up. I see a similar kind of sentiment within integrated projects where we want to make building information so cheap that only the rich will be able to go out on site and do a physical inspection. And not to say that on-site inspection won't have a place. Like I was interviewing a number of facility managers at the beginning of my PhD, and one thing that was amusing was that when I presented them this idea of a digital version of the building such that they didn't have to go to site anymore, they were almost saddened by that prospect. They're just like, going to site is the best part of my day. Otherwise, I would just be sitting at my desk. Why do you want to take that away from me? But, that's kind of a conflict of interest. The employee enjoys the waste of time, whereas the employer, sees it as a cost. I don't know. That's a question for management to decide. But in any case, we do want to reduce the need, the necessity for on-site inspection. And only those that can afford the luxury will do in the on-site inspection. I think that is where automation will take us, is that when presented with a question, budget will not be even a consideration when clicking the BIM It button. In fact, most people will just click the BIM It button by default on a regular basis to just update all of their information, such that when there is a question or a project, they don't even have to, go to vendors, get quotes. They don't have to deal with any of that stuff. Define, specifications for the type of information they need and the accuracy that they need. Like, the information will just be there. Like, it will be accessible when it is needed. That is the ambition of automation, is to make it so cheap that everyone just has information when they need it. I think it's a question that we're all wrestling with right now with the release of ChatGPT, with the release of these image generation models, with the recent release of OpenAI's Sora that's generating these beautiful videos. We're all wondering, like, is there going to be a place for me in the productive world very soon? Or is my work going to be taken over by the bots? I kind of think of this as like a hierarchy thought exercise where I'm no longer responsible for, transporting vitamins from my stomach to my thigh. That is a process that is entirely autonomous. And I'm not sitting here thinking to myself, like, gosh darn it, why have my cells and my immune system and all of these biological processes automated this job away from me? Like, what am I going to do with my time now that I'm not shuttling vitamins through my system? No, it is a gift that it has been automated. Otherwise, I would have probably lost my mind with all of the individual decisions that my body is making without any direct input from my conscious mind. And I kind of see it as like a pyramid, a hierarchy, where there are processes at the bottom, there's a massive volume of them, and we've kind of figured those out. We've automated them. And then, every time a process is automated, we simply elevate to a higher level of the hierarchy. Because vitamin shuttling has been automated, I can now sit here and talk to you via these information technologies about digitizing the universe. Work is going to follow a similar pattern where the existing strata of productive activity will be automated. Maybe not comforting the elderly in old age. That will almost certainly remain a human responsibility. But the things that are amenable to automation will be automated, and we will elevate to a higher layer within the hierarchy. It's impossible to answer what that elevated layer is going to look like because it hasn't been invented yet. That's probably the first job that we will have once our job is automated, is to invent the next layer of the hierarchy. And so for the building professional, when we automate away the drudgery of tracing walls and windows and pipes and ducts within point clouds, such that we can represent an existing building in a building information model, the question will then be, okay, where is the automation failing? Okay, for the time being, I will find responsibility in augmenting the AI in cleaning up the mistakes that it's making. Okay, that's one responsibility. The next responsibility is, okay, we provide a kind of a standard service where we, deliver an LOD 250 plus model with only the components defined in the execution plan. Well, that doesn't actually meet the needs of a user perfectly tailored to their situation or project. Well, someone has to do that tailoring. The automation will serve as a kind of a standard deliverable, and then the humans will then tailor the standard deliverable to a very specific case. That kind of tailoring will probably also eventually be automated, but it's not going to be the first thing that's automated. So building professionals will find responsibility there. And then finally, the model doesn't actually serve all of our kind of Maslow's hierarchy of needs. Just because you have a model doesn't mean that you have achieved self-actualization, or it doesn't mean that you have experienced joy in a new activity, or whatever it is that makes life meaningful. Humans will have to then take the information and take it over that last mile. How do we take an existing model and solve climate change? Automation is not going to be able to make that leap. It's going to bring us closer and closer and closer to the answer. But we will always have a role in taking what is available and achieving the highest things that are on our, to-do list, whether it's solving climate change or eliminating suffering through hunger or, inspiring the next generation by going to Mars. It's just going to require some creativity from us.
I think if successful, will enable a large part of the architectural engineering industry to focus less on, can we produce 3D models? I think we can all collectively agree that the value that design professionals bring to the industry is not spending time answering what is there, but rather like what should be. And I think that the more that we can empower them to be able to quickly answer that question, the less time they have to spend on kind of picking up the pieces. I'm super excited. I think very much still day one, and yet we've got a lot more to go. I guess before we wrap up, what's the next 3 months, 6 months, 9 months hold? I mean, are we going to crack Scan-to-BIM, or are we? What's 2024 look like for us?
So you've assembled an excellent team. I'm working very closely with my colleague Ted Weber, who worked at Amazon as a machine learning engineer. And I'm working with Pat and his team, world-class QA/QC and eye to detail. Murray in South Africa, always ready to respond to a query. Like, it's crazy how responsive he is. Like, as soon as I finish writing the message, he's already responding. And I guess that's the benefit of working at a startup, is you can work very fast and iterate fast. And it's always hard to make predictions with innovation because there are always unforeseen circumstances and challenges. But I can say that we are working as hard as we can to crack this. And I know there are people waiting for the easy button of Scan-to-BIM. Like conference after conference after conference, I say that I'm working on this. They say, oh, thank God. When are we going to get it? We're going to start off with the simple architectural things. I think that is a reasonable expectation for this year, is we will have cracked walls, windows, doors, columns, floors. That is a fairly safe bet.
I saw the recent prototype that you shared. It was incredibly. I had to watch it about 4 or 5 times over. The logic is there. I guess now it is the challenge.
Now it's just execution. Yeah.
Yeah. No. I guess seeing where to start to break down, what are the kind of the edge cases, etc.
Yeah. And I wish that it was just an execution challenge, but it's also a design challenge and figuring out which direction to steer the ship. Because simultaneously with figuring out all of the technical issues, we're also trying to figure out what should we be automating in the first place? What is going to provide value in the short term versus what do we need to achieve in order to crack full Scan-to-BIM automation in the long term? And yeah, that presents a challenge in and of itself. And then, of course, like how do we release this in such a way that our existing infrastructure and company is receptive to what is being released? Again, I'm confident that we will have automated most of the architectural scope by the end of the year. And then it's going to be a question what we do next. Do we focus on automated reports? Do we focus on mechanical furniture, industrial scopes? If anyone listening has an opinion, reach out to me. I'm eager to hear people's opinions on what we should do after architectural scope.
Yeah. Maybe to close it out, share with any potential aspiring engineering student, architectural student, folks that are interested in this field of study, like what's your message to them?
There's this really beautiful story about some oak beams in Oxford College in the UK. I think at the turn of the 1900s, there was an entomologist, a scientist that studies bugs. He was like poking around amongst all of the beams in the dining hall. And he realized that they were kind of full of beetles and they were rotting. And he said, well, that's interesting for me, maybe not so good for the school. So he approaches facilities and he says, these beams are going to have to be replaced soon or we're going to have a disaster on our hands. And the school's administration gets together and they say, where are we going to get beams like this? Like, the building had been constructed many centuries ago out of old oak, most of which has been clear cut since. And so one of the younger administrators, he says, maybe someone has thought of this. Let's call in the forester. So they call in the forester and they say, hey, you know what would be great? If we maybe have some oak trees somewhere on university property that we can use for these beams. And the forester says, well, we were wondering when you would be calling, because when the school was first constructed, we simultaneously planted a grove of oaks, knowing that eventually the beams would need to be replaced. And so because of that foresight, we do indeed have the trees that you need. It's incredible to imagine that kind of stewardship in the modern age, where they were acting in such a way as to benefit those who would live hundreds of years in the future. Right now, we're kind of dominated by quarter-to-quarter reports and what is the next deliverable and how am I maximizing my KPI, with almost no mind of making the life of someone in the future easier. Of course, we talk about sustainability and we talk about mitigating climate change, but who is actually willing to stop driving to work? Like, it takes a very strange kind of person to sell their car and start biking through the Canadian winter. If I was going to give a young aspiring engineer a piece of advice, is to desperately seek moments of stewardship like this, because that is the kind of thing that will nourish your soul, is if you can go to sleep knowing that you've done a job well, so well, in fact, that for generations, people will thank you for what you have accomplished.
You've got me choked up a little bit here. But I guess on that note, great way to close out what I consider to be part one of a multi-part conversation. I think the work that we're working on now and likely will continue to see different milestones on, my hunch here is that we're going to have to do a part two fairly soon.
Yeah, this was a blast, Jose. Thanks for inviting me.
Of course, man. Of course. A lot more folks in the industry need to see and hear what you're leading. And so I would not be surprised if we had engineers from all over wanting to knock on your door and help you out with this challenge. So I'm excited to see that play out.